Welcome to Civil Engineering Edge. In this video, we'll break down the complete design process for a 500 millimeters into 500 millimeters square column and its square footing. Whether you're a student or professional engineer, this step-by-step approach will help you master column design as per IS 456 standards. Let's get started. Section 1. Given data and problem statement. We have a 500 millimeter into 500 millimeter square column carrying an axial load of 1,500 kilonewton. The safe bearing capacity of the soil is 225 kilonewton per square millimeter, and we are using M20 grade concrete and Fe 415 grade steel. Let's begin by designing the column reinforcement. Section 2.
Visual: a modern construction site with reinforced concrete columns being erected. Welcome to Civil Engineering Edge. In this video, we'll break down the complete design process for a 500 millimeters by 500 millimeters square column and its square footing. Whether you're a student or a professional engineer, this step-by-step approach will help you master column design as per IS 456 standards. That is main title of this design is Column and Footing Design Simplified Step. By a step guide for civil engineers, let's get started. Section 1. Given data and problem statement. Visual: problem statement appearing on screen with a 3D model of the column and footing. We have a 500 millimeters by 500 millimeters square column carrying an axial load of 1,500 kilonewtons. The safe bearing capacity of the soil is 225 kilonewtons per square meter, and we are using M20 concrete and Fe for 1. Let's begin by designing the column reinforcement. Section 2. Column design. Load on the column W equals 1,500 kilonewtons. 1. Calculate the factored load. PU equals 1.50 x 1,500 2,250 kilonewtons. 2. Calculate gross area of column. A equals 500 by 500 equals 250,000 square millimeters. 3. Calculate required steel area ask. Area of concrete equals AC equals 250,000. Ask mm2. Fy ask equals 2,250 by 103 0.40 by 2,250,000 plus 0.67 x 400 equals 2,250 by 103 Ask equals 925.75 square millimeters. Lateral ties design. The diameter of the lateral ties shall be not less than 1/4 diameter to the longitudinal bars equals 20 quarters equals 5 millimeters. 5 millimeters. Provide 6 millimeters Phi ties. Pitch of lateral ties. The pitch of lateral ties shall not exceed the following. Least lateral dimension of the column equals 500 millimeters. 16 times the diameter of the longitudinal bars equals 16 by 2,320 millimeters. 48 times of the diameter of the ties equals 48 by 5,288 millimeters. Provide 6 millimeters Phi ties at 250 millimeters CAC. Section 3. Design of the foundation. Load on the column equals 1,500 kilonewtons. Approximate weight of the footing at 10% of column load equals 150 kilonewtons. Total load equals 1,650 kilonewtons. Safe bearing capacity of the soil equals 225 kilonewtons per square meter. Thus, area of the 2.75 meters. Net upward pressure intensity equals P equals 1,500 by 103. 2.75 x 2.75 equals 198,347.11 per square meter. Depth from BM consideration. Critical section for bending moment is shown in Fig. Projection beyond the critical section equals to 750 add 2 equals 1,125 millimeters. Maximum bending moment, M equals 198,347.11 x 2.1.1 to 5 to 345,170 Newton meters. Factored moment. Mu equals 1.50 m equals 1.50 x 345,170 equals 517,755 nm, equating mu dot limit to mu. 0.138 FCKBD2 equals 0.138 by 20 by 500 D. 5 bars at a clear cover of 60 millimeters. Effective cover to upper layer of bars equals 60 plus 12 plus 6, 78 millimeters. Overall depth required equals 613 plus 78 equals 609. The depth may be increased by 30% to limit the shear stresses. Provide an overall depth of 900 millimeters. Actual effective depth D, 978 equals 800. Welcome again to Civil Engineering Edge. In this video, we are here for the design process for a 500 millimeters by 500 millimeters square column and its square footing. Whether you're a student or a professional engineer, this step-by-step approach will help you master column design as per IS 456 standards. After previous depth from consideration, punching load equals column load. Reaction on column area equals 150,000,1983 for 711 x 0.50 to 1,450,413 on. Factored punching load equals 1.50 x 1,450,413 equals to 1,175,619 50 on. Design punching shear stress for M20 concrete equals 1.80 on MN2, equating, hence provide an overall depth of 900 millimeters as determined earlier. Mu BD 517,700 x 1,000 per 500 by 8,222 equals 1.533. Percentage of steel required equals PT equals 51 square root 1. 4.60. 20x 1. Ast equals 0.47. 100x 500 by 822 equals 1,932 square millimeters. Similarly, provide 18 bars of 12 millimeters phi in the other principal direction also. Check for shear, check for one-way shear. The critical section for one-way shear is considered at a distance equal to the effective depth from the face of the column. Let the depth of the footing at the edges be reduced to 300 m. So, overall depth at the critical section D equals 900, 900 to 300, 1125 x 822 equals 461.60 millimeters. Effective depth at the critical section D equals 461.6 to 78 equals 383.6 millimeters. Shear force at the critical section equals 198,347.11 x 2.75 x 0.303 equals 165,272.701. Factored shear, VU equals 1.50 x 165,272.70 equals 247,909 on. Width of the footing at the top at this critical section equals B plus to D equals 500 plus 2x 800. V equals VU, bead equals 247,909, 2,144 x 383.6 equals 0.30 on per square millimeter. Area of steel provided equals 18 by 113 equals 2,034 square millimeters. Percentage of steel provided equals 2034 2144 by 822 x 100 equals 0.12%. Corresponding IC equals 0.28 Un per square millimeter, practically equal to EV. E check for two-way shear. The critical section for two-way shear is taken at the periphery surrounding the column at a distance of half the effective depth. Overall depth of the footing at a distance, D2 equals 8 to 22, equals 411 millimeters from the column face, equals 900 to 300, 1125 x 411. Equals 680.80 millimeters. Effective depth at this section equals D. Equals 680.80278 equals 600 to 0.80 millimeters. Critical perimeter B equals for 500 822 equals 5,288 millimeters. Shear force at this critical section equals V equals 198,347.11. 2.752 to 1.3 to 22 equals 1,153,352. Factored shear equals VU equals 1.50x 1,153,352 equals 1,007 x 600 to 0.80 equals 0.54 Un per square millimeter. Beta C equals short side of column section. Long side equals 1. Ks equals 0.50 plus C equals 0.50, but Ks should be limited to 1. Permissible design shear strength thick equals Ks x 0.5 square root FCK. 1x 0.5 square Un per square millimeter 1.12 an IC, and that's it. We have successfully designed the column and its square footing using fundamental structural design principles. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more civil engineering content. See you in the next video.
Welcome to Civil Engineering Edge. In this video, we'll break down the complete design process for a 500 millimeters into 500 millimeters square column and its square footing. Whether you're a student or professional engineer, this step-by-step approach will help you master column design as per IS 456 standards. Let's get started. Section 1. Given data and problem statement. We have a 500 millimeter into 500 millimeter square column carrying an axial load of 1,500 kilonewton. The safe bearing capacity of the soil is 225 kilonewton per square millimeter, and we are using M20 grade concrete and Fe 415 grade steel. Let's begin by designing the column reinforcement. Section 2, column design. Load on the column. W equals 1,500 kilonewton. 1 to calculate the factored load. Pu equals 1.50 into 1,500 is equal to 2,250 kilonewton. 2 dot calculate gross area of column. A equals 500 into 500 is equal to 250,000 square millimeter. 3 dot calculate required steel area. ASC. Area of concrete equals AC equals 250,000 ASC square millimeter. Ultimate load Pu equals 0.4 FCK AC plus 0.67 FY ASC equals 2,250 into 103 Newton. 0.40 into 20, 250,000 ASC plus 0.67 Zeno 415 ASC equals 2,250 into 103 Newton. ASC equals 925.75 square millimeter. Provide 4 bars of 20 millimeters GIA, 1256 mm2 for lateral ties design. The diameter of the lateral ties shall be not less than 1/4 diameter to the longitudinal bars equals 20 divided 4 is equal to 5 millimeter. 5 millimeter. Provide 6 millimeter dia ties. Pitch of lateral ties. The pitch of lateral ties shall not exceed the following. Least lateral dimension of the column equals 500 millimeter. 16 times the diameter of the longitudinal bars equals 16 into 20 is equal to 320 millimeter. 48 times the diameter of the ties equals 48 into 5 is equal to 288 millimeter. Provide 6 millimeter jet ties at 250 millimeter center to center. Section 3. Design of the foundation. Load on the column equals 1,500 kilonewton. Approximate weight of the footing at 10% of column load equals 150 kilonewton. Total load equals 1,650 kilonewton. Safe bearing capacity of the soil equals 225 kilonewton per square millimeter. Thus, area of the foundation equals 1650 divided 225 equals 7.333 square meter. Side of the footing equals square root 7.333 equals 2.71 meter. Provide 2.75 meter into 2.75 meter. Net upward pressure intensity equals P equals 1500 into 103 forward slash 2.75 into 2.75 equals 198,347.11 Newton per square meter. Depth from bending moment consideration. Critical section for a bending moment is shown in figure. Projection beyond the critical section. SAD face 2,750 to 500. Divided 2 is equal to 1,125 millimeter. Maximum bending moment. M SAD face 198,347.11 into 2.75 into 1.125 into 1.125 divided 2 equals 345,170 Newton meter. Factor moment. Mu equals 1.50 m equals 1.50 into 345,170 is equal to 517,755 Newton meter. Equating mu.lim to mu. 0.138 FCKB D2 equals 0.138 into 20 into 500 D2 equals 517,755 into 1,000. D equals 613 millimeter. Providing 12 millimeter gel bars at a clear cover of 60 millimeter. Effective covered upper layer of bars equals 60 plus 12 plus 6 is equal to 78 millimeter. Overall depth required equals 613 plus 78 is equal to 691 millimeter. The depth may be increased by 30% to limit the shear stresses. Provide an overall depth of 900 millimeter. Actual effective depth, D equals 900 minus 78, is equal to 822 millimeter. Depth from punching shear consideration. Punching load equals column load. Reaction on column area equals 150,000, 198,347.11 into 0.50. 2 equals 145,0413 Newton. Factored punching load equals 1.50 into 145,0413 equals 2,175,619.50 Newton. Design punching shear stress for M20 concrete equals 1.80 Newton per square millimeter. Equating punching shear resistance to the punching load for into 500 into D into 1.80 is equal to 2,175,619.50 D equals 604 millimeter. Hence provide an overall depth of 900 millimeter as determined earlier. Mu divided BD squared equals 517,755 into 1,000 divided 500 into 8222 equals 1.533. Percentage of steel required equals 51 square root 1 dash 4.60 divided 20 into 1.533 divided 415 divided 20 equals 0.47%. AST equals 0.47 divided 100 into 500 into 822 is equal to 1932 square millimeter. Provide 18 bars of 12 millimeter GIA. Similarly, provide 18 bars of 12 millimeter GIA in the other principal direction. Also, check for shear. Check for one-way shear. The critical section for one-way shear is considered at a distance equal to the effective depth from the face of the column. Let the depth of the footing at the edges be reduced to 300 millimeter. So, Overall depth at the critical section. D equals 900, 900, 300. Divided 1125 into 822 equals 461.60 millimeter. Effective depth at the critical section D equals 461.6. 78 is equal to 383.6 millimeter. Shear force at the critical section equals 198,347.11 into 2.75 into 0.303 is equal to 165,272.70 Newton. Factored shear. VU equals 1.50 into 165,272.70 is equal to 247,909 Newton. Width of the footing at the top at this critical section equals B plus 2D equals 500 plus 2 into 822 is equal to 2,144 millimeter. Nominal shear stress at this section. For sad face, VU divided BD equals 247,909 divided 2,144 into 383.6 equals 0.30 Newton per square millimeter. Area of steel provided equals 18 into 113 is equal to 2034 square millimeter. Percentage of steel provided equals 2034 divided 2,144 into 822 into 100 is equal to 0.12%. Corresponding IC equals 0.28 N/mm2, practically equal to 4. 2. Check for two-way shear. The critical section for two-way shear is taken at the periphery surrounding the column at a distance of half the effective depth from the face of the column. Overall depth of the footing at a distance. D divided 2 is equal to 822 divided 2 is equal to 411 millimeter from the column face. Equals 900. 900 to 300 divided 1125 into 411 equals 680.80 millimeter. Effective depth at this section equals D equals 680.80. 78 is equal to 602.80 millimeter. Critical perimeter B equals 4. 500 plus 822 equals 5,288 millimeter. Shear force at this critical section equals V equals 198,347.11. 2.752 to 1.3222 equals 115,335 Newton. Factored shear equals V equals 1.50 into 115,335 equals 173,0028 Newton. Nominal shear stress 4 equals 173,0028 divided 5,288 into 602.80 equals 0.54 Newton per square millimeter. Beta C equals short side of column section divided long side of column section equals 1. KS equals 0.50 plus beta C equals 0.50 plus 1 is equal to 1.50, but KS should be limited to 1. Permissible design shear strength IC equals KS into 0.25 square root of secant. 1 into 0.25 square root 20 is equal to 1.12 Newton per square millimeter. So, for nominal shear stress is less than IC, permissible design shear strength. And that's it. We have successfully designed the column and its square footing using fundamental structural design principles. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more civil engineering content. See you in the next video.